and this is a function of it will partial differentiation. It will be for function of more than one variable. So function of more than one variable, when we say function y is equal to, when we say y is equal to x square, then it is function of one variable. So if we write x is equal to y of say 1, this is equal to 1 square, like this. So when it's a function of more than one variable, then we write this as function of xy more than one. So x and y are independent variable and z depends on x and y. So f of xy is equal to z, and this f of xy is root over 9 minus x square minus y square. So just like y is equal to x square, y1 is equal to 1 square, then like that, in a similar way, f of just so f of say 2 0 2 0 is equal to z of 2 0, means what, in place of x, f of x y, so first coordinate is x, second coordinate is y. So first coordinate we have to write, so 9 minus, in place of x we will write 2 square, 2, and it is x square, so it is this, and minus 0 square. So value is this. So in this way we find the value for this. So it is 9 root over 5, like this. So this is function of more than one variable. In a similar way, if we write f of xy is equal to x cube plus y square minus twice x. So what we write here, f of say 2 0. So 2 0 is, in place of x we write 2, so it is 2 cube plus 0 square minus cos of 2. Or if we write f of 0 2, f of 0 2 also we can write f of 0 2. So first coordinate is 0 2. So first coordinate is 0, means what, 0 x is 0, 0 cube plus 2 square minus cos 0. Cos 0 is 1, so we get this value. This we have to see from the table, and this value is 4 minus cos 0 is 1, so this is equal to 3. So this is function of more than one variable. So f of x y z, it is x square by 3 minus 2yz square. So if we write f of say, three variables are here, so f of say 1 4 say minus 2. So what we will have here, so it is 1 cube, in place of x we write 1 cube by 3 minus 2 into 4 into, in place of z we have to write minus 2 whole square, then plus 6 into, in place of z we write minus 2, then into x is 1, into y is what, 4. So 4 to the power 5, 4 to the power 5. So you put find the value. So it is equal to, this is 1 by 3 minus 4 into 16 minus into 32, then minus this one is minus 12 into 16 square, like this. So you find the value. So these are function of more than one variable. In a similar way, here we have this is function of 4 variable x, y, z, w. So all are all are independent variable here, and that value that we write for this, say we can write this as t also. So this t is equal to this. So this t is will the dependent variable. Then definition of meaning of partial derivative. So you know what is derivative of a function. Now when you say partial derivative, it is function of two variable. So function of two variable we are considering function of two variable first. So what we do here, our actually when we say ddx of say ddx of ddx of x square is equal to, what we say here, limit x plus h whole square minus x square divided by h as h tends to 0. So this is derivative of function. Now when we say partial derivative, suppose our function is say function is say z is equal to say x plus y. In this case, what we do, so dx of, so we write partial, so two variables are there, so we write partial derivative of x plus y. So we give increment to x only, not y, and this will be our equal to limit h tends to 0. So it is x plus h. So we are giving increment to x plus y. We keep as it is, minus x plus y. So we are, when we say with respect to x, so we are giving h, we are adding h to x only, not y. So divided by h. So this is the value. So y and y will go cancel. Y, there is no, means y is unchanged here, no change in y, and that is why partial derivative of, when we have to find partial derivative of with respect to that particular variable, then we have to keep increment for that variable only. So this is with respect to x, so we are giving increment to x only, not y. So ultimately what happens, so del x of, so if we write del x of say x cube y, in this case this is like, because y is not changing, so we keep y as it is. So suppose y is 4, y is 6, means we behave y as constant, and then this is ddx of x cube with respect to x, because it is single variable, so it is like ddx of x cube, and that is 3x square. So 3x square into y, so this will be 3x square into y is equal to 3x square y. So this is partial derivative. Similarly, if we say del y, this is delta symbol actually. So del y of x plus y, this is same as this. So limit k tends to 0, so we keep x as it is, because it is with respect to y. So x, then add k to y, then minus x is as it is, y is changing, and divided by k. So means x is unchanged. So in this case del y of x cube y will be what? y, we are taking with respect to y only, so x cube is as it is. So del y of x cube y is x cube only. So del y of x cube y is equal to x cube. We considering is x cube as constant and y derivative of y is 1, so it is 1 into x cube. So this is this partial derivative. So these are some examples. And one thing we can we have has not defined before. We have not defined before this hyperbolic functions. So hyperbolic function, this sine hyperbolic x, it is defined as e to the power x minus e to the power minus x divided by 2. Cos hyperbolic x is e to the power x plus e to the power minus x divided by 2. Like this, tan hyperbolic x, cot hyperbolic x, sec hyperbolic x, cosec hyperbolic x, etc. And these are derivative. So ddx of sine hyperbolic x is cos hyperbolic x, ddx of cos hyperbolic x is sine hyperbolic x, etc., etc. So you can see these things, and you will need it later. You have to remember these things. Then let us see these examples. F of xy is x cube y minus thrice x plus y square plus 1 equal. This f xy z, this is equal to root over x square plus y square minus 4. Then this is so just like this, and as we discussed in the previous this one, like this one, we can have the values for derivative. It is partial derivative for x and y. So this thing you get clear, then we will discuss some other things later.